Yes, yes, Harini.
Sir, you were telling something. I joined
Yes.
now.
No, nothing, nothing.
Okay, sir.
Right. So almost 25 students have joined now. Let us start with it's called right. Yeah. So in the last class, we were discussing about uh, called accessories, requirement of chain surfing, and there are some the tripod, ranging rods, prism. So all these accessories and plumb knob and line rangers, and also it's called a lathes and ranging poles, and these are the arrows, pegs, and ranging rods, and also the tape and yeah, and measuring the horizontal distance by speedometer, tapes, odometer, and also with some plasmometer and pedometer, different types of measurement of horizontal distance. And yeah, before that we could classified the different maps and topographical maps and all those things. uh, One thing I would like to tell you that, do you have any doubts on the topic which you have covered so far? These are the fundamental one, and it's only the theory part. And do you have any doubts on it? Because it is not a new things for you, because it is a completely trigonometry and it's a mathematics. Okay, but as far of now, it's just a what you call theory part we covered this here. eh? So maybe in the next week onwards there will be a problems, very simple problems, and you can easily solve those problems. Okay, and you must understand what is what are the instruments you are going to use it for survey part, and what are the the accessories you required, and what is the concept of that, what is the function of the all the the equipments, eh? Those things, and errors, how the errors are occurring there, and what are the different types of errors. Okay, and how we need to rectify this. And rest of the part is that the scales, when you are surveying the maps, how you are going to plot those things with the required scales, and how to set up the scales. The ground information you need to put it into the paper in a systematic way. Okay, and also the contours, these are the imaginary lines which connects the same elevations. Okay, the contours generally it is not connect crossing each other. As I told you that, this I forget, I think the contours are not crossing each other. You see the the beauty of the contours, and also it is a typical nature of the contours. Actually it's the imaginary lines, we call it the imaginary lines. It's connect the equal elevation. All these places, this is the equal elevations. This is equal elevations. Okay, so it is not connect. It is not crossing. If you cross it, there may be some problem with your data. the ground data which you are surveying, which you are covering, which you are acquiring from the ground, there is some problem. That's why it is crossing. Otherwise, it will not be crossed. Okay. So this is the things. Yeah. And when you cut the the contours, any plane of the what you call this plans, or maybe the geological cross section, or it may be a profile cross section, you can easily build up like this. This is a AB is the cross section of these particular areas, and you can y-axis contours, x-axis is the distance. Distance may be the 50 meter, and this is a 50 meter. Okay, and this is a RL elevations. Okay, 100 to 500, maximum 500, minimum 100. So this is a minimum for 100, maximum 500. So that when you take each contact here in the line 1, 2, 3, 4 with a scale, okay, you can connect it and transfer those contacts into the these lines, and you can mark it to the okay. First contact is 100. Okay, you are marked here, but you need to mark on the wherever the required, wherever the 100 is there, 100, and next one is the 200. Okay, that may be here like this, and it may come like this. It will come like this. This is a hill. This is how you need to connect the things. These are the things. So do you have any doubts on this? So far we covered the topics. I need the questions. Otherwise, I understand that you understand the things. I can go ahead with the next class. I mean the scales. What are the scales are? How we are going to fix the scales? Okay. How to read the topo sheets? Okay. What are the features in the topo sheets? Okay. Okay, Harshavardhan, let me ask you then in that case. Harshavardhan, Harini,
Yes, sir.
do you understand the concept of the basic surveying and the fundamentals, whatever we discussed so far?
Yes, sir.
Okay, that's great. Manish, oh, it's left. Okay, Manoj Kumar, yes. Manoj Kumar, Ahmad Sanif.
Yes, sir.
Yeah, do you understand what we discussed so far, the topics in the basic surveying?
Yes, sir.
Okay, how about Neha? Renuka?
Yes, sir.
Okay. Who is the CR here? Class representative?
Darshini and Vishnu.
Who is?
Darshini and Vishnu.
Visruta.
Yes, sir.
Visrut and Darshini, na? Okay, okay. Let me note down the things. Darshini and Visrut. Okay. Oh, where is Darshini here? Okay. Visrut Gowda, right?
Yes, sir.
Okay, okay, okay. Right. Yeah. How about Rohit? Sharat Kumar?
Sir.
Yeah, do you understand the basic concepts? Suprasad?
Yes, sir.
Okay. Shraddha Patil?
Yes, sir.
Do you understand what we are discussing?
Yes, sir.
Whether it's a fast or slow, how? Is there any, the things are, not understanding, you can express here only so that we can, rectify the things here. Okay. All right. Okay, is this, and then Sreshta?
Yes, sir, understanding.
Okay, that's good. That's great. And Sridhar?
Yes, sir.
Okay. Tarun?
Yes, sir.
Yes, sir.
Okay. Yadunandan?
Yes, sir.
Okay, yeah, right then. Thank you. So far we discussed the very basic concepts: measurement, units, classification of surveying, principle of surveying, and you know objectives of the survey, uh, and also the errors, how the errors are encountered, happening there, types of error: human error, instrumental error, natural errors. Okay, and the different types of surveying: compass survey, theodolite survey, dumpy level, auto level, uh, and also the what you call the total station survey, and these are all ground-based surveys. And there will be a airborne survey. In that, there will be drone survey and aircraft surveys, right? And yeah, these are all the types of surveys. So okay, and yeah, where we are going to do this now. Let's go with yes. Okay, so accessories. In the last class, we discussed about the chain surveying and what are the accessories required for the particular survey. For any type of survey, you need the these accessories: pegs, ranging rods, plumb bobs, hand labels, and arrows, chains, tapes, and all you required for that. Okay. And if you go for chain survey, or if you go for plane table, or it may be a dumpy level, auto level instruments, you need those accessories. Okay. So then now, ranging a survey line. How you are going to ranging the survey line? What do you mean by that? So when the survey line is low, survey line is longer than a chain length, it's necessary to align the intermediate points. Say for example, where is it? Figure here. Okay. Say for example, A to B, it is your station points. From A to B, you need to survey it. How much the what you call this length is there. What we will do? This is a plain land, plain view. There is no undulating topography. There is no hill and valleys. It is a plain land, plain land. Okay. For that, that is the easiest way. When it comes to the the undulating topography like this, that is a very difficult part. You have to make the intermediate points, because it's not visible. A to B is not visible properly. Not properly in the sense completely it's not visible. That time you need to fix the intermediate points, then go to the next point. That is how the things are going to change it. Some noise is coming, right? Right. I hope everybody is mute the voice speaker. Okay, maybe half. Okay, right. And this is ranging a survey line. Survey line in the sense, it may be your pipeline survey, or it may be your road survey, or it may be a a railway track survey, or maybe a tunnel survey, or maybe a canal survey. So when the survey line is longer than chain length, it is necessary to align the intermediate points on survey line. Don't depend on the okay, I can take it from A to B. It may be a 1 kilometer length. There may be a lot of the bushes, or it may be curves. You cannot see that properly. So for that, you need to have the intermediate points in between, 1 or 2 for the the points you required and convenient, and so that you can easily or smoothly complete the survey. Those things you need to establish, okay, in between A and B point. Okay, the process of locating intermediate points on survey line is known as a ranging. Ranging in the sense, the ranging rod, that is your range. Okay, point A, you are standing on the point A. You want to survey from point A to point B. Okay, and it is not what you call the the chain length is not that much. So in that time also you need to establish the intermediate points. Okay, that intermediate points, the intermediate points locating the or establishing the intermediate points, we call it as a ranging. We should that point should be visible. Okay, the method of ranging or classified as a direct ranging and indirect ranging. There are two types in a ranging. Okay, ranging is nothing but establishing the intermediate points. Okay, that's called a ranging, and there are two types we classified. One is direct ranging, next one is the indirect ranging. So what is the direct ranging then? So if the first and last points on the survey lines are intervisible, it should be clearly visible, intervisible. Okay, that is called a direct ranging. Okay, say for example, I show in the picture here, in the figure shows that the points A, B in the survey which lines intervisible. Now it is necessary to locate the point C on line AB, which is slightly lesser than the chain length from A. So here your chain length is very less. You need to survey up to here, up to B point. So that's why you need to establish here, because otherwise what happens if you go on manual survey, it's not a scientific way. And also if you are putting the chain is up to here and you can again you are establishing here, measuring the things, that's not going to happen, and you will get more error there. It's called human error as well as your instrumental error. Okay, that's why first you establish C point, then you go with the next point, D, E, F, like this. So A and B are your two stations. Okay, in between you can establish the intermediate points. Okay, that is how the things. So here shows that B is the survey line which is intervisible. Now it is necessary to locate the C points on line B, which is slightly lesser than the chain length from the A. Okay, and for this you need the two persons, and one person in the instrument side and another person is in the what you call establishing the locating the point, marking there on the ground, and handling the chain or a tape. Okay, we needed 2 to 3 persons for this. At this point, A and B ranging rods are erected on both sides for alignment. The assistant of survey positions himself as close to line AB as possible at a distance slightly lesser than the chain length and hold the ranging rods. So this is an alignment. Generally, for aligning the one line, generally roughly most of the people are doing it village side, or maybe they don't have this. Those who don't have the total session or maybe the theodolite, they used to put the 3 sticks or 3 persons, make the line alignment. So here also doing the same thing. Intermediate point also we are doing that. That's because of get the perfect alignment. Okay, so this is a direct what we call this ranging. Okay, this is how the things. These are the 2 points, main points A and B, and we are going to establish because of our chain length is very less. So first we'll establish the C point. From here again we'll establish another point because chain length is not reaching up to the B point at one stage. Okay, and here this is a plain view where is a plain land. There is no obstacles, there is no bushes, there is no turnings, so that you can easily do it. But still, if the chain length is very less, that time you have to establish the intermediate points. Okay, if your chain length is very big, bigger than this A to B length, so you can easily one stage you can finish the survey. Okay, so that's how the things. But here in the and the down below, this one especially, yeah, this is a little bit undulating topography. So from A to B is not intervisible. So we have to establish C point. Then you can reach. Then you can see the B point there. Okay, and simple principle is the same for plane view and the sectional views. Okay, that's how the things. So here, that is a thing. The survey or position himself approximately 2 meters behind the A, and the sides ranging at ranging rods at A and B that hold like this on both sides. Okay, and it moves to the left or right of the line AB till he finds the ranging rods. Okay, that means A, B, C, all 3 points are in one alignment. If you see the first person, if you stand in the fourth person there and making the align of 3 persons, like 3 points A, B, C, you should not see the second person itself. That means that is the best alignment. Otherwise, if one person is here and there, the line cannot be properly ranging it or align it. Okay, that's how the things. So here the surveyor should always observe at lower portion of the ranging rods, lower portion of the ranging rods, not upper portion of higher side of the ranging rods. The signals used in the instructing the assistant at C is while ranging. So he should get the signals, or he can talk with the C point persons. Okay, and indirect rangings. What do you mean by indirect rangings? Okay, if the two endpoints on the line to be measured which are not intervisible, maybe a curved line, maybe a lot of turnings, maybe there is a lot of bushes, thick forest. It's very difficult to do the survey in that areas. So this is an indirect ranging. If the two endpoints of the line to be measured which are not intervisible, the surveyor has to go to indirect ranging. This is also we call it as a reciprocal ranging. Okay, the visibility of points may be due to the unevenness of the ground. That means undulating topography. Uneven is nothing but it's undulating topography. There may be a small hill, valleys like that. Okay, unevenness of the ground, and due to a long distance, okay, it may not be the visible. That's the one thing. Other thing, ground is uneven ground. Third thing is also there. If there is a bushes, if there is small trees and grass are there, that is also possible. It's not because it's not visible there. Okay, so this is the things. It shows the cross section of the ground is typical case of invisibility point of B in the case. Okay, so this is how we are indirect ranging this ones. Yeah, you can see this. This is sectional view, and same thing is in the plane view. Here is in the sectional view, you can see this. It is an undulating topography. From A to B, you can easily see that. Sorry, A to M, and M to N, you can see that, and M to N to B, you can see that. So here, your first initial point is A and B. If you want to survey from A to B, you have to come with a 2 or maybe a 3 the interlocating points, intermediate points. You have to establish. Otherwise, you cannot now measure the distance from A to B. So for that purpose, we need to establish from A to M, whatever the possible visibility is there. Say, for example, from A to B is maybe a 4 kilometer, or it may be 1 kilometer. Say, for example, 1 kilometer. So it's not visible because it's a hilly areas. So here up to 400 meters, or it may be a 300 meters, it's a visibility is there. Then you establish there whatever the possible. Then again you establish here. Then again you establish the another point, another intermediate points, that's called a N. From there you can establish you can reach up to the B point. This is how we need to do the survey, and with the direct ranging and indirect rangings. Okay, this is with the same plan view, and this is a sectional views. Okay, and here that's what we discussed there. The persons at M and N position themselves near to the M and say that M1 and N1. Okay, and that is a A and B. The A is direct person at M to come to M2, so that A, M2, N are in the same line. Line measurement as well as the alignment should be the proper. Okay, You cannot go here and there. You cannot move it. Otherwise, your drawing will be the, will not be in the proper way that. Okay. And here is the measurement of distance on sloping ground. It's another typical problem. So when the ground is very flat land, there is no undulating topography. So that time what happens? You can easily do the survey. When there is a sloping ground, when there is a steep hills, when there is a small mounds, there is a difficulties are there. Okay, in surveying, horizontal distance are required. But if the ground is sloping, there are two methods to get a horizontal distance. One is direct method. Again, it's a indirect methods. Okay, I think we have the figure here. Yes. Right. Here there are two methods. One is direct and another one is the indirect methods. Okay. So in the direct methods, this method is known as method of stepping also. Okay. Since the line is measured in a smaller step length. Okay. And let the A be the length of line and which is measured on a sloping ground. The surveyor holds the tape or it may be a chain firmly at a point, and the another person later goes to the convenient length of 11 of tape, say, and 5 meter, 10 meter, and 15 meter like that. Okay. Then after ranging in the sense alignment, leaders hold the chain horizontally. Okay. Then he may be guided by the surveyor or the other in the party, or horizontally you can fix the tape. So first you measure that the ground, whatever is in the shape, so then you make it straight. That is the one thing. After stretching the tape with the help of a plumb knob, that should be the properly plumb knob. Keep the ground and the tape. It should not be the bent one. By dropping a pebble, that is a rough method. Plumbing bob is the best one. Okay, that we can easily get the proper positions. The leaders transfer the end of the tape to the ground and mark it. Okay, so length of the tape selected, that is in the drop, never more than a eyesight of the leaders. Okay, that means when you are marking it, you should mark it properly there. Okay, that is the things. So here, how we are going to do this? As I told you this, and this is actual length you need to collect. But slope is not like this. It's not. It's a horizontal one. It's a very plain land. You can say that. But slope is like this. Okay. You can tape. You can fix the tape here. Another person can fix it here. But he has to raise this tape up to the height of this so that he can get the complete length, or you can establish the intermediate points and get it done. That is another way, so that you will get the A to B length, slope as well as your the length of that. Okay, that is how we need to. This is steps wise. Station 1, 2, 3, 4, and 5. Okay, this is P1, P2. E3, this is a step like that. This is how you can measure the things. Okay. And in a second method, the difference in the level H, see here, it's a slope ground, and this is A point, and this is a B point here. It's inclined positions here. And so here the difference in level H is measured by knowing, the sloping ground I. So here is the height of this. H is the height, and A and B are the 2 points. Okay, and the equivalent horizontal length L can be calculated. This is a horizontal length. This is the inclined length, and this is a height difference. L is equal to square root of L square minus H square. L square is the horizontal, the inclined length, and minus H squared. That's the height of this horizontal one, H squared. So this is a easiest small simple formulas, and you can easily calculate those things. right? And this is not visible properly there. Third method, that's most useful when the intermediate points on line are to be used to taking the offset. Offset is in the sense when you are doing the theodolite or dumpy level, first you have to establish one point, then you have to go on into establishing the intermediate points. So when you are going for the first intermediate points, you first establish that point and you shift the instrument to that point. To confirm again your instrument point, you have to take the back reading of the previous point, so that you will get the positions and proper the marking place, the locations. That is called your offsets. Okay, and yeah, this is the things. And here is the precise measurement. What do you mean by precise measurement? And baseline measurement. The precise in the sense accuracy, that is most important. And baseline for any project, the one baseline is most important. With reference to the baseline, you can establish the number of the survey lines. So a baseline is an important line in a skeleton of the triangulations used for preparing the maps. Okay, while preparing the maps, it's normally the first line to be drawn over which the lines are drawn from the triangular skeletons. That is for the area calculations, or it may be establishing the any other lines. The with respect to the secondary lines, the other lines are filled with. Okay, so here is that the baseline is to be measured more precisely, accurately. You have to measure it. If you done any mistakes in the baseline, if it is not done it properly, or if it is not done very accurately, it will be give a problem for our rest of the drawing. So the baseline is to be measured more precisely to minimize the errors. You cannot say 100% you can control the errors. You can minimize the errors in surveying. Okay, for the length, for the measurement of baseline, you can use the steel tape, or you can use the other the tapes. Okay, and you have to take care a lot for that. Okay, all right. So while stretching that tapes also, there will be a lot of what you call this the error. It may happen. Sometimes you are stretching the tape, sometimes you are just holding the the tape. That is also giving the error. So it is just like a mathematics that involves the trigonometry. So you need the accurate, the perfect, the angles, length, and alignment. If you are not measuring properly the alignment, or the the what you call the length, or it may be the angle, so it will give you a lot of the the errors. Those errors are very difficult to rectify it. Instead of rectifying it, you can do the survey itself immediately. That is how the best way, because distribution of error is so difficult, and you cannot distribute the error 1 or 2 points. If you surveyed the 50 points, so you have to distribute the complete error into the all the 50 points, not at 10 points or 20 points. Otherwise, again, the drawing will not be a proper way. Okay, the instruments which are used for for various persons may be differ slightly, but basic method of baseline measurement should be a proper. Okay, so person to person's error may be increased, okay, or it may be decreased. Okay, that's how we call it as a human error. Okay, sometimes instruments may give the what you call due to overheat, it may give the wrong readings, but it is not 90% what you call this it's nearest to the answer, but it's not exact one. We need the exact one, because it is survey. So again, the error may encountered here. Okay, so here these are the things which we have discussed here. So the direct method, indirect methods, and yeah, chaining and slope surveying. How we are going to do the slope surveying? That's in the direct method and indirect methods. And most of the the slope surveying, it happens especially in the tunnel areas, where they are doing the uh, tunnels in the hilly areas, and also in the ghat sections, ghat section area, hilly areas, where they are doing the roads, construction of the roads. That place, this most of the the slope, the distance measuring on the slope areas, getting the lot of errors. The accuracy, the well experienced, the surveyor should be deployed for the particular areas. Otherwise, all the your surveyed points will be get errored, and it will be a big mess up for that. Okay, this is the most important one, taking the ranging one. Okay, and horizontal, and this is a one. Okay, right. And yeah.